Hello, ladies and gentlemen. Today we're going to start our unit on stoichiometry. So, this includes everything from balancing equations to naming equations and on. After today, you should be able to calculate the number of moles of a substance that can be produced or consumed using a mole ratio. Describe the ways in which balanced reactions can be interpreted and review the basics on how to balance equations. So the word stoichiometry comes from two Greek words, stoichion, meaning element, and metron, meaning measure. Stoichiometry is actually the study of quantities as it relates to chemical reactions. So if we look at different chemical equations, they can be interpreted in several different ways. One of those ways is the number of molecules that are found. So if I look at the number of molecules on my reactant side, I have N2 and then 3 molecules of H2, yielding 2 molecules of NH3. So it can tell us the number of molecules that are there and how they relate to each other. Another way is by looking at the mass. The mass of the reactants and the mass of the products should always be equal. So we're going to show that by finding the mass of N2 at 28.02, the mass of 3H2 at 6.06, and then 34.08 grams is the mass for NH3. When we add them up, they do indeed equal. So they're always equal. Another way is to look at the number of moles of things that are there. So this tells me that there is 1 mole of N2 here, that there are 3 moles of H2, and that there are 2 moles of NH3 of ammonia. This is a relationship that we will focus on. Because it tells us the exact number of moles, we can use that to convert. The coefficients in the balanced equation represent the smallest whole number mole ratio between reactants and products. So here's an example of mole ratios for this particular reaction. You are just going to write the coefficient in front as the number of moles. So if I look at the relationship between N2 and NH3, I have 1 as my coefficient, or 1 mole of N2 is equal to 2 moles of ammonia. If I look at the relationship between H2 and N2, I have 3 moles of H2 is equal to 1 mole of N2. And finally, if I look at the relationship between NH3 and H2, I have 2 moles of NH3 is equal to 3 moles of H2. We can use this in order to calculate or do some mole-to-mole calculations. So we're going to do if 3.86 moles of potassium reacts completely with excess water, how many moles of hydrogen would be produced? First thing we need is our equation. Okay? And this will always be given to you, never going to make you go from words to the equation. So first thing we need to do is make sure it's balanced. Remember, we write out all of our elements, and then we count how many we have. The only thing here that isn't balanced is our H. So we need 2 of those. That also changes our number of OH. So then we have to change our number of OH over here, which changes our number of potassium and our number of OH. So now we need to change our number of potassium. And then everything is equal. So we need those coefficients in front. Okay. Now with those coefficients, we're going to use that to convert in our mole problem. So if 3.86 moles of potassium reacts completely with excess water, how many moles of hydrogen will be produced? So our known 3.86 moles of potassium. Our unknown, how many moles of hydrogen? Okay. Start with our known and put it over 1. Then we're going to convert from moles of potassium to moles of hydrogen. So I use the molar ratio here. I have moles of potassium here. So I know on my next bottom I have to have moles of potassium. When I look, the coefficient is 2, so I'm going to write a 2. On top, what am I going to? Moles of H2. If I look in front of my H2, I have no number, so I know it's a 1. And that is where I want to end up. So I am done. I just need to do that math. 3.86 divided by 2 is 1.93. And our unit is whatever's left up here, moles of H2. And that is our answer 1. Now, don't forget on all of these, you have to show your known, your unknown, and your work here, as well as your balancing now. To go through another example, we have how many moles of aluminum will react with 0.512 moles of hydrochloric acid. First, I'm going to change hydrochloric acid to HCl, and this again will all be given to you. So we are going to have our equation here, and we're going to need to balance it. So I have aluminum, hydrogen, and chlorine. One, 2, 3. Start with chlorine, so I need 3 of those. That changes my hydrogen to 3 and my chlorine to 3. So the only thing that doesn't match now is my hydrogen. The best I can do between a 3 and a 2, the lowest common multiple, will be a 6. So I'm going to multiply this hydrogen by 3. And I'm going to erase that 3 and put a 6 here. That hydrogen by 6, which also changes my chlorine. Now my chlorine is 6, so I need a 2 in front of the ACl. That changes my aluminum to a 2, so I need a 2 as a coefficient there. So once we're done balancing, then we can use those mole ratios to get whatever we want. And now I'm going to go ahead with my problem. For my known, I have 0.512 moles of HCl. For my unknown, I have how many moles of aluminum. Start with my known and put it over 1. In my next problem, I know on the bottom I need to cancel this out, so I need moles of HCl. On the top, I write what we're going to, moles of aluminum. So what's the coefficient in front of HCl? It's a 6. What is the coefficient in front of aluminum? It is a 2. You can simplify that to 1 over 3. So then you're just going to take your 0.512 and divide it by 3. When we do that, we should get 0.17 moles of Al. That is all that you are doing today. If you guys have questions, please let me know. I know we're reviewing some old concepts, so if you need to watch a refresher, go back and watch a refresher from before. Have a wonderful day, and please let me know if you have any questions. Bye-bye.